Okay, thank you so much. Thank you for the invitation. It's a wonderful conference. This is my paper. It's Coordination Causes Coarse Concepts, and that's my email if you want to have any comments. And I'll be around if you want to talk. So. Yeah, exactly. More comments concerning coordination causes coarse concepts. Okay, so this is the argument. When a group has a greater need to coordinate their actions, the group uses concepts that are more blunt and less specific. So I'll define what this means in a second. So the argument is that concepts result not just from bounded rationality, kind of individual cognitive processes, but from a social process. That is, our groups need to coordinate. Okay. All right. So let's talk about concepts. So I just have a bunch of objects up here. Each object has attributes, size, color, like whether you can eat them, whether you sit on them, or whether you drive them, whatever. Okay? We can group these objects into concepts based on these attributes. So obviously, we use concept every day, all the time, like what these things are. So say that I take these things. What makes an object a chair? Well, I can say that those things are the chairs. Okay? That's the concept. It's a category. Okay? What makes an object a chair depends on some of these attributes, and the Oxford English Dictionary says a chair is a seat typically having 4 legs and a back for one person, like not a sofa, for example. Okay? What is meant by typically is a certain attributes that is 4 legs and a back are correlated. And you can see that some of these things, I would call that a chair, even though it doesn't have 4 legs. So the correlation is not exact. Okay? I'm not sure I would call that a chair. You see, so there's fuzziness, obviously, right? Okay. So again, the concept of chair is not completely unambiguous. Okay, this is a classic example of a bird. A bird typically has features including like feathers, wings, a beak, can fly, etc. Okay, so we all agree that an ostrich isn't a bird. So it's pretty clear that by the definition, an ostrich is a bird. However, an ostrich seems not quite a bird because it doesn't fly. That is, it doesn't have one attribute which is usually correlated with all the other ones. Okay. So the idea that a concept is based on this kind of correlation of attributes, and the name for this is often given is the exemplar. This is a theory which comes from, usually attributed to Eleanor Roche from the 1980s. And so what I'm going to ask in this paper is, why are concepts based on correlated attributes? Okay. And there's a few answers. One, which is given by Murphy and Medin, is that correlated attributes exist in the real world, and it's natural to group things in this way. That it's natural to say that, we see lots of animals about. Some of them have feathers and wings, and they fly. So that's the natural correlation we observe. So we'll all call those things birds. That's this explanation by Roche here. But we're going to have a different answer, which is that we use correlated attributes for concepts because they help in coordination. That is, it's not just about the actual world. In some sense, concepts are not completely grounded in objective reality. They're grounded in our mission, our social use of these concepts, in some sense. Okay? Okay. All right, in the model, people can communicate using attributes that are correlated or independent in the probabilistic sense. So using independent attributes is more informationally specific, and it makes sense. Why would you use attributes which are correlated with each other? Because they're just giving you the same information. Right? Why would you use that twice? Okay. The problem is when you see a single attribute, a person is unsure whether other people also see it. Okay. Whether when you see several correlated attributes, what you think is, I see that thing's a bird. And not only that, I think that even if you don't see a few of those attributes, you're going to also conclude it's a bird. Okay? So concepts based on correlated attributes are coarser. There's a waste of information. Okay? But they better generate the common knowledge needed for coordination. This is the argument in the paper. Okay. So let me give you some examples. Here's a person. This person's, I think, presenting as male. How do I know that person's male? Well, you can look at their haircut, clothes, watch, belt. And what's amazing is how many of them there are. There's a lot. Like, I woke up this morning and I put on male socks. Like, what's the point of that? It's just socks, right? So, why are there so many? And these are not given. These are endogenous, right? These are all human choices. Okay, why so many? This is another little picture. Okay. This correlation of all these attributes seems so strong that even a single deviating attribute makes us kind of almost upset or struggle cognitively. So this person on the left, they're carrying that bag. Who owns that bag? Oh, we don't know for sure, but how would you infer that? Well, I think my general heuristic is if you're carrying a bag, it's very likely you own it. Okay? So this bag is owned by the person on the left. Okay, how about that bag? Let's use the heuristic. Well, it obviously belongs to the person to the left. But most people would not make this conclusion. What would you usually conclude in this picture? What do you think? Yeah. Yeah, exactly. This person is carrying this person's bag. That argument is based on correlations, essentially, right? Basically, that people who look like that, who are wearing those shoes, those pants and stuff, tend to wear bags which are not like that. However, people who are wearing clothes, et cetera, hairstyle like that, tend to wear that bag. That's basically it. But it's not just correlation in the sense that we make a judgment based on correlation. It's almost like, this is almost a little upsetting. It's like I almost want to give the person to that right person your bag or something like that, right? It's almost like it makes a scramble almost cognitively. Yeah. So yeah, it's interesting, and like I said before, huh? It's possible, exactly, exactly. The interesting is this is wasteful informationally. Why would you use so many things? So sure, I can understand why you want to communicate your gender preferences or whatever, but why do I need to do it like so many ways? In so many, like my name, my hairstyle, everything. So why is this so often? Why not just use one or two attributes to signify male and then use like other attributes like to signify like, what kind of food I like, what kind of TV I like to watch, that kind of thing. Okay. And the answer is concepts are based on many correlated attributes because of social coordination. Society deems it important that we agree on a person's gender, for example, and constantly if you disagree. If you present as male using just a single attribute, I may see the attribute, but I'm not sure that other people also see it. Okay? However, if I observe several attributes of maleness, I'm more confident that even if you don't see a few of them, you'll see at least one. Okay? And therefore, you'll have the same judgment I will. Okay? That's the argument. Okay, so again, being male using several correlated attributes better generates common knowledge that the person is male. Each person is more confident, everyone else thinks the person is male. And in these results I'll show you, which are basically just a bunch of examples, the greater the need for coordination, the more attributes need to be correlated. And hence the coarser, less nuanced the concept. So what is it? Huh? Sorry?
This is going to be a social attractor in some kind.
Yeah, I guess, yeah, exactly. I'm going to change like the parameter of coordination, how much you care about coordination. Yeah, exactly. And so as I change that thing, it'll change kind of like the base in some sense. But this is going to be a standard Nash equilibrium thing. I'm not going to do that, but you can think of it that way, exactly. Okay. Anyway, if people use a lot of correlated attributes, that means is it's a coarser concept because it basically means you're repeating yourself many, many times. Okay. Here's some real-world examples. This is an interview of Bill Clinton and George W. Bush after their presidencies. Clinton says, "What surprised me was that you're so far removed for the American people." This is when he became president after being governor of Arkansas. "It's hard for them to see you as a three-dimensional person. We were just used to being people and dealing with people in Arkansas. And it really surprised me how easily I could be turned into a two-dimensional cartoon instead of a three-dimensional human being, and you have to discipline yourself." In other words, as a politician on the national scale, he found he had to simplify his communications, and he was seen as more of a caricature, less nuanced. Okay? Clinton states, again, going from a small answer to a bigger one, you have to be more cartoonish, less nuanced concepts, and you also have greater message discipline, which means basically repetition. You say the same thing over and over again. How do I explain this? These are the kind of the bounded rationality ones. You could say the Arkansas residents are just better at communication than US residents in general, so they can handle more nuance, but I don't think that's true. You could say Arkansas news media was better at communicating nuance, but I don't think that's true either. It really has to do with the scale of communication, the scale of mobilization necessary. Okay. This is another example. So Jim Farber is an early gay rights activist. He agrees the understanding now common in our day and age of sexuality and gender as fluid. However, in the 70s and 80s, he said it was very important to use blunt distinctions. That is, for example, it was crucial to come out as unapologetically gay and not just bisexual. Okay? And the argument is this. The focused ideology you need to stoke a younger movement isn't given to fine distinctions. Okay? It's as blunt as an advertising campaign and with luck as effective. The emphasis wasn't on encouraging people to discover their sexuality for personal fulfillment, but on megaphoning a stark bulletin for public consumption to bolster the movement's profile and message. In other words, the identity and kind of concepts we use to talk about individual sexuality, maybe with one person, is different from a political movement. It's a different scale. Okay? For two-person interactions, you can be nuanced about your sexuality. Okay? But for political reasons, you have to use blunt distinctions. Okay. This is a similar kind by the philosopher Judith Butler. If sexuality is to be disclosed, what we'll be taking is the true determinant of its meaning. Surely it's more complicated. There are many things it can depend on. I'm permanently troubled by identity categories. However, politically, isn't it quite crucial to insist on lesbian and gay identities precisely because they're threatened with erasure? That is for political purposes. Okay? That is the blunt identity categories, i.e. lesbian, necessary for large-scale political mobilization, actually conflicts with how you interact with just one other person. Okay, all right. A little historical example. This is Marian Anderson. 1939, she gave a very famous recital on the steps of the Washington Monument. It's because she was originally supposed to give a concert in the hall, which is owned by the Daughters of American Revolution. They said, we're not going to rent it to you because you're African American. So they did it outside here. It was considered a founding moment of the 20th century civil rights movement in 1939, an iconic movement in the history of American democracy, etc. However, if you asked Anderson herself, I would be fooling myself to think that it was meant to be a fearless fighter. She didn't think of it as political at all, basically. She just did what her management told her to do. And she thought, this is just another concert. She didn't think of herself as political. But then she thought later, I could see that my significance as an individual was small in this affair. I had become, whether I liked it or not, a symbol for my people. What's the point here? The meaning of this experience was obviously very nuanced for Anderson. Okay, very kind of like, I like the concert, but however, for the history, it was not nuanced. It was a moment which is iconic, period. Okay? So what's the difference? It wasn't like people in the audience could not understand this nuanceness, but rather at a large scale, it has to be in some sense blunt. Okay? It has to be a unitary meaning. Okay? Not rich in some sense. Okay, all right. This is my model. Okay, so I'm going to explain these things. Okay, here we go. So it's a really simple model. It's just a bunch of examples, really. So I have two doctors. Okay, they're in an office that responds to patient cases. Okay, there's Imax possible patient cases, the probability of case size pi. Each case has attributes. Okay, you have it as maximum J max attributes, and we'll say that all the attributes are they're non-empty and pairwise disjoint. And there's also an ideal point for each case. So the idea is that two doctors are in a medical office, somebody walks in, and they present with symptoms, okay? And you're not sure which case it is. Is it like tuberculosis? Is it like, arthritis or whatever? Okay, you look at the attributes and try to make a treatment based on that thing, okay? All right, so when a case arrives, again, the intake nurse announces a subset of the attributes. With probability E, a given doctor does not hear a given attribute. Okay, so there's a little bit of error, communication loss. After the announcement, simultaneously, Dr. 1 chooses a treatment X1, which is an RN, and Dr. 2 chooses X2, which is an RN. Okay, and this is person 1's utility. What is this? This is kind of like what Rachel did, except that there's an objective best response. So this is like objective best treatment. This is how far you are from the ideal treatment. ZI is the ideal treatment for case I. So you want to choose, Dr. 1 wants to treat something which is close to ZI, but also doesn't want to do something too far away from the other person. Okay, so there's an element of conformity, of wanting to be like the other person, but you also want to do the correct treatment. Does that make sense? Okay. All right, so doctors 2 is like that. And what's this K here? K is simply the coordination loss parameter. If K is 0, it means all you care about is choosing the right medically necessary treatment. If K is large, it means you care a lot more about doing the same thing as the other person, as the other doctor. Maybe you don't want your treatments to conflict or something like that. Okay. This is a game of incomplete information. We can compute a Nash equilibrium. That's it. This is the model. That's all it is. Okay.
Sorry, I missed it. What's Z?
Oh, Z. Yeah. It's for case I. It's the optimal treatment given that case. So if you knew what that case is, this is you can think of it as like how much medicine to give or something like that. Okay. All right. Okay, so again, Dr. 1's payoffs are this. Again, you want to be close to the ZI, and you also want to be close to your colleague's treatment. And what is this thing? This is simply the squared Euclidean norm. Okay, so it's just quadratic loss. Okay, it's pretty simple. Any questions about the model? Are you okay? Okay, all right. Let's do the very simplest case. 2 cases, and there's just one attribute. So you have either people come in with a fever or a cough. Okay, and your job is to figure out what medicine to give them. So they come with a fever, that probability is 1/2. Probability of a cough is 1/2. If they come with a fever, you give them like 6 milligrams of Tylenol. If they come in with a cough, you give them 4. That's the ideal treatment. Okay. The nurse announces the attribute, the first one. What are our parameters? This model just has 2 parameters. E is the probability that an announcement is not heard. It's the error rate, so in some sense the loss rate. And K is the importance of coordination. Then we can simply compute an equilibrium. Okay. Before we compute an equilibrium, the first question is, what is a strategy? Okay. All right. So what is a strategy? This is coming straight out of Aumann. A strategy is a function from states of the world to an action measurable with respect to your partition. Okay? So I really love that whole way of thinking about things. So what is a partition? So what are the states of the world? Okay? This is case 1, that it's, I guess, fever, and both doctors hear it. We hope that that's pretty likely. Okay? This is the case where it's a fever and doctor 2 does not hear it. Okay? This is the case where it's a fever and no one hears it. Right? This is where it's a cough and both hear it, et cetera, et cetera. Okay? So there's actually 8 states of the world in this very simplest case. Okay? All right. These are the probabilities of those things. Remember, the probability it's a fever is 1/2. The probability that it's lost, the message is lost, is E. So this is the probability of this state, right? Probability of fever and the probability that both messages are lost. Okay? Et cetera, et cetera. Any questions about that? Okay, so these are the probabilities. These are your partitions. So this is Dr. 1's knowledge of the world. Okay? These two, by putting them in the same kind of bubble, it means that person 1, Dr. 1 cannot tell these apart. What does this mean? It means that person 1 knows it's a fever, but doesn't know whether person 2 heard that. Okay? In this case, it's person 2 heard it's a cough, but doesn't know that person 1 heard it's a cough, but doesn't know that person 2 heard it. In this case, person 1 doesn't know anything and does not know whether it's a cough or a fever, and also doesn't know what person 2 heard. Okay? All right. Does this make sense? Okay, so it's a partition. All right. So it turns out that you can just write this as 3 numbers because your action has to be measurable with respect to this partition. This is simply what you do if you hear fever. This is what you do if you hear cough. This is what you hear if you hear nothing. Okay, so just 3 numbers. Okay, this is Dr. 2's partition. Okay, and it's just very similar. Okay, but again, person 2, if person 2 doesn't hear anything, they don't know what the case is, and also they don't know what person 1 hears. And it turns out there's so much because of symmetry. These are, I don't know if they do X1 and X2. These turn out to be all the same. Okay? This is simply what a doctor does if they hear fever, what they do if they hear nothing, what they do if they hear cough. Okay? All right. Any questions about that? So these are the strategies. So just 3 numbers on both sides, and they happen to be the same. So actually, just everything's just 3 numbers. Again, a strategy in equilibrium is represented by these 3 numbers. Okay, and then going back, so nurse attribute announces the attributes 1, etc. So you can solve for the equilibrium. This is it. That's all it is. Just one big example. Okay, so what is 5? 5 is like the average best treatment. Okay, if you knew nothing about what the cases were, you simply pick 5. Okay, and then you have this thing here. What's this? We're going to explain this 1 over 1 plus EK thing. Okay, so again. I wrote the equilibrium here. What's the interpretation? This is, again, the 5 is if you didn't hear anything, you just choose the middle, okay? Because that's the best. You're not sure about what the case is, and you just might as well do the middle thing. Let's look at this. What if E is 0? If E is 0, then this is 1, so X of fever is 6. Okay, why is that? It means that if there's no possibility of error, you'll simply, and you hear fever, well, you know it's got to be fever, so you just give them 6, okay? Because there's no possible error, so you know that your colleague will go along with you. It doesn't matter how much conformity there is, because you know that they will hear it for sure. Okay. What happens if K is 0? Okay, this is now, you could have error, but you don't care whether you do the same thing as your colleague. Okay. If K is 0, this is also 6. Okay. Why is that? It's because I hear the message and I think, oh, well, it's possible my colleague did not hear it. And in that case, they'll choose 5. But I don't care what my colleague does anyway, so I'll simply choose the right thing medically necessary. Does this make sense? Okay. So the interesting thing, however, is when E and K are both non-zero, okay, this means that there's some probability that the message is lost, and you do care about what the other person does. Okay? What are you going to do? Okay, so I hear fever. Okay. I'm thinking, some probability my colleague did not get that, and I do care a little bit what they do. So if they didn't get the message, what will they choose? 5, right? Exactly. They'll kind of go to the middle. So I have to think, oh, it's possible that they will choose 5 because they didn't get the message. And since I care what they do, I'm going to move a little bit toward 5. You see what I'm saying? But in addition, I have to think about what if they did get the message? What will they do? Will they do, in this case, 6? Well, no, because they will actually be doing the same process which I just did, yes? Right? If they hear the message of fever, they're not going to necessarily do 6 because they will also shade toward 5 as well, right? So that's the equilibrium process, okay? All right, so how do we find this equilibrium? Again, it turns out in this quadratic loss world, best responses are just averages, okay? So my best response if I see fever is, it turns out that your best response is an average of what you kind of your preferred point, the medically necessary thing, and what you think the other person will do, okay? If I hear fever, the weights of that average is given by K. Okay, so the larger K is, the more I care about this. This is how much I care about the actual best treatment. This is how much I care about what you do. Okay, so it's an average of 6, and this thing, what is this? This is simply what I think you will do, right? With probability E, you're going to play X of naught, which is 5, right? This is what you'll do if you don't hear the message. If you did hear the message, you're going to play X of fever. Okay? Does that make sense? Okay, so this is like a Nash equilibrium condition. Okay, it's very straightforward. One way to think about Nash equilibrium is, what if we didn't have Nash equilibrium? This would have to be, X of fever would be like my expectation of what you would do, right? And that would also depend on your expectation about blah, 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 blah. And so one of the best reasons for Nash equilibrium is just laziness. Instead of putting all that stuff, I'll just put X fever again, right? Instead of doing all this expectation stuff, just put the same thing in. Anyhow, when you put this in, you can solve for this, and you just get this. That's all it is. It's pretty straightforward. Okay. Any questions about that? That's what the equilibrium looks like. Okay. All right. Yeah, I should let me do an animation. Let me see if I can get this to work. Okay. Okay, so this is my, this is 5. Oh, sorry, 4 and 6. Yeah, this is 4 and 6. The dots are the optimal treatment, and the X shows the equilibrium strategies. Okay, I'm going to vary E and K. That's what these little sliders are. Okay. So when E is 0 and I say I increase K, what happens to the equilibrium strategy? Nothing. They just change. You still just choose the optimal points. Similarly, when K is 0 and E increases, okay, nothing changes. However, if both are away from 0, then this is what happens. Okay, as I increase either K or E, you shade more and more and more. Why is that? If I care more and more about you conforming to you as opposed to the optimal treatment, that means that I worry more and more about you not getting the message and playing 5. Okay, hence I move more and more in that direction. Does that make sense? Okay, what if E increases? If E increases, it means that I might not care as much I might care the same amount about what you do, but the probability that you will get the 0 and you will not hear anything and play 5 also increases. Yeah? Does that make sense? Oh, okay, thanks. All right. Okay. All right. Let's do this example. So, is that clear what we're doing? Clear? Okay, so this example is essentially most of the paper. Okay, we're going to have 3 attributes. Okay, notice that attributes 1 and 2 are completely correlated, 100% correlated. But every time attribute 1 is left, attribute 2 is west. Every time attribute 1 is right, attribute 2 is east. However, attribute 3 is independent of those things. They're all equal probability, and these are their ideal treatments. Okay, so the treatments look like this. We're in R2. Okay, this is case 1, left, west, up. This is right, east, up, etc. Okay. So if I just announce one attribute, it just looks like this. Okay. Notice the first attribute is just about whether it's left or right. Okay. If we do 2 attributes, then all that changes is that E becomes an E squared. Why is that? Because now I have redundancy. The probability that somebody doesn't get both messages becomes E squared as opposed to E. Okay. That's what this looks like. Okay, so in this space, this is when E equals 1/10, K equals 4. If I hear left, west, or just west, this is what I choose. So what's interesting is notice that I'm doing a good, doctors do a good job at sort of choosing the right treatment in this dimension, but they do not care about this dimension at all. They don't even communicate about it. They don't even know it. It's not even a thing for them. It's not part of the concept. All right. Now how about attributes 1 and 3? Now you're communicating both on the vertical and horizontal dimensions. And now you can do this thing. Okay, it's not the E squared, but with the E. Okay, it looks like this now. Okay, so now since I'm using attributes which are not correlated, it's much finer. I can now reach the entire space of an R2, what I need to do. Okay, however, I shade more, right, because each one has a little bit more probability of worrying about what the other person's doing. See, I hedge more towards 0. Okay. So let me show you how this looks in the animation. Okay. Okay. All right. I can get this a little smaller. Okay, let's do this one. Okay, so again, this is when you do the first two attributes. Okay, notice that things move more slowly, right, because it's now E squared as opposed to E. Okay. This is when you use attributes 1 and 3, and notice that it moves more quickly because you don't have that redundancy. And now I'm comparing these things. Okay, so look. Again, if K is 0, which is better? This is clearly better, right? If there's no conformity, you'd want to try to reach the whole space. You want to use fine categories. Okay, use independent attributes. Okay. However, as K increases, what happens? Now, this is the entire paper, basically, here. You notice that as people have greater needs for coordination, okay, the advantage of this is that it's more specific, so you get closer to the ideal points. However, the disadvantage is that these things collapse towards 0 much more quickly, okay? That is, the strength of this is that even though you're ignoring one whole entire dimension, at least in one dimension, you're doing pretty good, okay? So what I'm saying is that when E and K are away from 0, it's possible that you would not use the independent attributes. You use correlated attributes, even though you're throwing away information. And when you throw away the information, that's what's creating the coarse categories. The categories are coarse in the sense that from the doctor's point of view, these two things are exactly the same. Okay? All right. Okay, so let me see. Okay, so I compare these. Okay. And then this is the little picture here. What is this? This is simply a graph of E versus K. The shaded areas when persons 1 and 2 is the expected utility. These are the doctors. Sorry, this is the doctor's expected utility when attributes 1 and 2 are used. This is the doctor's utility when attributes 1 and 3 are used. Okay. In this large region, they'd rather use the correlated attributes as opposed to the uncorrelated ones. Okay. Because you can just simply calculate these things. Okay. When you use the correlated attributes, you have coarser categories. Okay. When you use the, so when E and K are both small, close to 0, then you do want to use the finer ones. Does that make sense? Okay. That's basically it. That's the entire intuition of the paper. Okay. All right. So we can also talk about the patient's expected utilities. Okay. You can just calculate them. This is just an example. What you can show is the patients themselves do not care directly about coordination. However, even they sometimes, when E and K are large enough, they would rather have the coarse categories. Okay, which is to me a little surprising. They'd rather have the doctors throw away some of the information when they're communicating. All right, so I'll do this example, then maybe you'll have questions. This is a very similar example. Okay, let me see. Do we have this? Oh, well, I'll just skip it. I don't know, maybe I won't skip it. The difference is this. This is where now, look, I'm making it so the variation in the x-axis is much smaller than the variation in the y-axis. Okay? Now, in some sense, you're throwing a lot away if you're ignoring the y-axis, okay? Because much more variation is there. Okay? Even in that situation, sometimes you'd rather use just communicating along the x-axis and use coarse categories. Okay, let's use this example. Okay, what is this? Now there's 4 cases. This one here, this one here. So the first two attributes are correlated. They indicate the left-right dimension. The third one is different. It's independent. It indicates the y dimension. Okay. All right. So the first two attributes are correlated, and hence they indicate this direction. So if you use both the first two correlated ones, then you can get pretty good along this dimension, but you've totally failed on this y one. Okay. If you use attributes 1 and 3, then you do pretty good in all of them, but not as well. Okay. So what you can show is that, remember, y was a probability of these two middle categories, two middle cases. Okay. What you can show is for Q and K, for E and K, farther away from 0, often it's better to use the correlated attributes, okay, even though you're throwing away a lot of information. Okay. And even when Q equals 3/5, this is the probability that these are the two middle states. Even when 60% of your variation is vertically, the doctors would still prefer using categories which ignore that, okay, ignore that heterogeneity. Okay. So this is an interesting case because if you're a person in case 2 and case 3, which one do you prefer? Do you prefer this or this? Huh? You're that person there. You really want to be treated that way, right? But in this, if you're only using the first two attributes, what are you seeing? Like this. Well, I mean, you don't get treated at all, basically, right? You see, you'd rather have something up there, yeah. But that's not happening. I mean, if they define the disease according to 3, you would get something, yeah. Okay, but you're not. So the point is here is that if you're in that case or that case, you truly are victimized in some sense by the need for the doctors to coordinate. Okay, you actually are kind of victimized by this categorization, this conceptual thing. Okay, all right. Okay. Any other? Oh, okay. I'll just do this one example. This is like a three-dimensional thing. You can either have all 3 attributes which are very dichotomous, or you can have something a little bit less, or something more heterogeneous, more nuanced, and then you can show that, like, yeah, for low E and K, it's optimal to have the finely based categories. But it's not that hard to find E and K which are reasonable, in which you create a dichotomy, even though you could treat each of these 8 cases separately. Okay? All right. Okay, that's it. Thanks. Yeah.
We have some time for questions.
All right, thank you. Yeah. Yes.
Thank you for the presentation.
Thank you.
I noticed that in your examples, the treatment space was at first a segment and then a square.
Yeah.
But I can think of instances where it's not the case. For instance, if your doctors are oncologists and the decision is surgery or no surgery,
right.
There is no in between, right?
Yeah, yeah.
You're not going to do a half a surgery.
Right.
So my question is, what happens to your model and your results if the treatment space is discrete or non-convex?
I think it makes it harder to get these comparative statics kinds of things. So I just want to make everything smooth for that. But I think the underlying intuition, I think, is strong. So, but I could do some of those, yeah. Yeah. Thanks. I'll try. Any questions? Oh, thank you.
Just wondering what would happen in your model if you, let's say, two agents wanted to miscoordinate?
Oh, the miscoordinate. Oh, that's interesting. So, for example, I think in this case here, say the doctors wanted to miscoordinate, then I think if you're in case 2 or case 3, you would actually like that, right? It would make it harder for the doctors this region would become smaller. Yeah. So, I mean, I think you could show, like, maybe from the decision-making point of view, say you have a committee, maybe it's better for actually people to dislike, have anti-coordination to make a better judgment than coordination in some sense. Yeah, perhaps. Questions? Oh, yes, thanks.
Thank you so much for the presentation. I have
Thank
more
you.
of an interpretation question. It's like, when you outline it, try to like relate this like back to the initial discussion
Yeah.
on like social categories and social identity.
Right.
accept like these like black and white categories and how like politicians, for example, become.
Okay, so yes, so I think it does apply to all categorizations, which is like a huge, huge set of things, like objects, whatever. But of course, it relates to this. So one immediate result is that if I give a big speech, I will tend to use I won't use sarcasm. I won't use any kind of nuance. I will simply have very black and white categories, or very, very clearly defined categories. And so like, I once went to a recital by someone who was a Broadway singer in like a small bar, and she was singing full out. Okay, and I'm thinking, this is not right for the context. So there's like, if Obama gives a big speech, okay, and uses pretty strong kinds of like, really kind of coarse categories, and then you talk to them later in a one-on-one, of course you'd be kind of like, what's going on if he uses the same categories in this one-on-one conversation, right? So in a small group conversation, you would obviously expect a person to use much more nuanced language, much more careful concepts, but this is the reason why they wouldn't in a large context. That's kind of my thinking. So it is true that like, you could say that like very, simplification of nuanced issues is a result not of our inability to think of these things, but rather our the need to mobilize this on a large scale. So I think that's good.
I have a question, Michael.
Oh, sorry, thanks. Thank you.
Peyton once posed a question to me, which I never satisfactorily answered, and that is, for example, we have this notion of identity, and think about the identity of being in a strict religious sect or group. There's a certain standard of dress that goes with that. And even very minor deviations on one dimension attract severe sanctions, right? It's not really sort of very gradual.
That's kind of like what you're talking about before,
Yeah. Could this,
I'll try it, yeah. I'll put it in there.
Maybe a way to, I never developed a satisfactory explanation, but maybe this is the basis for it.
Yeah. Going back to your question, it's kind of like, there's this kind of commonplace thing that's like, I watch, the TV and like all these huge like, distinctions between being us and them. But when you just sit down and have dinner together, you realize we're all the same. We can all talk about what we like, we don't like, all these things. But the point of that is that's inherent in communication. Yeah. That's not something which is like a product of our times. Inherently, when you're talking about something in large mobilization, because of coordination reasons, you would have to use coarse concepts. That's the idea of this model. And so, I guess if your action is something like, your question would be something like, if I'm like talking about, dress with like my family or just my friends, I would be necessarily more nuanced about like the way we dress and all these things. But in the context of a political mobilization, we would have to be more harsh in some sense, more dichotomous, more binary, something. Yeah. Thanks. Thanks.
In your setup, people's preferences are given regardless of what happens. But in practice, I wonder whether the preferences themselves might not be a response to the need for coordination.
No,
and what I have in mind is the fact that in politics, at least American politics, certain attributes seem to be correlated for no obvious reason. For example, if you take someone who doesn't believe in climate change, you can attach a pretty high probability to what they will think about gun regulation.
Right, exactly.
There's no particular reason why those things should be correlated. You can see why, for reasons of coordination, they might be correlated, but that seems to have an additional effect, which is that the person himself
absolutely.
tends to have rather strong beliefs about both those things. And so there may be an additional feedback loop in it that is not yet in your model.
That's true. There are results like, if you ask people like, do you care if your kids marry somebody of opposite political party? 60% of people didn't care in 1970. Now it's like 20.
Now they do.
Now it's a huge amount. So why is that?
And this correlation has increased over time.
Yeah, exactly, right.
And
That's-
despite a political party.
I mean, you could say that, I mean, for example, I think some people have argued like abortion rights, abortion has been like one of the most successful political campaigns of all time in the sense that it causes huge realignment in the Republican Party. Like Nixon didn't take a position on abortion, for example, right? And you could argue, this is maybe a little bit analogous, the reason you could do that is because abortion is a situation where it's hard to have nuance. You're basically for it or against it. So you're not going to be able to do the same thing about like defense spending or something else, which is inherently continuous. Maybe something like that, you know. Yeah.
Thank you very much.
Okay, thank you, thanks. Thank you.